Good day, engineers. Para sa video natin na to is ang gagawin natin, tutuloy natin yung sample problem number 2 pero kukuha tayo ng properties kagaya ng steel ratio na balance, steel ratio na raw max galing sa kanya kasi na-prove naman na natin na doubly reinforced siya. Remember, yung mga ginamit natin na maximum steel ratio kanina is ang ginamit natin doon is for singly. Kasi yung derivation nun nanggaling sa assumption from the stress diagram na C is equal to T. And this equation is just for a singly reinforced beam. Ngayon, na-prove kasi natin na meron na siya ay isang doubly reinforced. So, we have to change yung balance steel ratio niya from a singly to a doubly. So, para makuha natin yung steel ratio niya from a doubly, so we will start with the strain diagram, which is this one, and kunin natin yung balance na C. So, to get the C balance, syempre, this one is, ito yung C na balance. Then, same procedure, ibababa natin yung 0.003. Dito, sa part na to. Then, we will have a ratio and proportion or the use of similar triangle. So, yung first triangle natin has a height of C balance over 0.003 is equal to that is yung height ng bigger triangle, which is itong triangle na na-create na to. So, that will be D over the base, which is 0.003 plus Fs over Es. Then, after that, we have to arrange this value. So, C balance yung kailangan natin hanapin. So, mareretain dito sa C balance and we will have 0.003D over 0.003 plus Fs over Es. So, galing dito, alam natin na yung denominator pwede natin yung gawing, so, E over Es natin, or yung Es natin is 200,000. So, that is the least common denominator nitong nasa denominator natin. So, 200,000 divided by 1 times 0.003 is 600. Plus, 200,000 divided by 200,000 is 1 times the Fs is Fs. So, yan na ngayon yung nasa denominator natin. Tapos, copyhin natin yung numerator na to. So, syempre, after that, yung denominator, pwede natin yan kunin yung reciprocal para ma-multiply sa numerator. So, that will be 0.003D times 200,000 over 600 plus Fs. So, ang lalabas na C balance natin will be 600 over 600 plus Fs. Pero since, sabi nga natin, we are on the balance condition, so ibig sabihin, itong Fs over Es na to is magiging Fy over Es. So, syempre, this will become Fy now. Kasi, sa balance condition, we assume na lahat yan nag-yield. So, alam natin na mag-yield yung steel na yan on the tension side. We don't know yung compression side na steel kung mag-yield din. So, this will be now yung C balance natin. So, ito, palitan na din natin na this will be Fy and this will also be Fy and this is Fy. So, after getting that one, pwede na ngayon tayo mag-substitute ng values dito para makuha yung C balance. So, that is 600 over 600 plus 414 times yung effective depth ng doubly reinforced na beam natin, which is 390. So, the value of C balance will be 3,000 over 13 mm. pwede natin kunin yung A balance gamit to, which is equal to 0.85 ng C balance, which is 0.85 times 3,000 over 13. So, ang A balance natin will be equivalent to a value 2550 over 13. So, meron na tayong A balance at C balance. Ngayon, syempre, since napatunayan natin na yung beam is doubly reinforced, ang gagamitin na natin ngayon na stress diagram is ito. So, kunin natin. Hindi na kasi pwede. So, ito na siya. Hindi na kasi pwede yung C is equal to T. Kasi, na-prove natin na this is a doubly reinforced. So, invalid na yung C is equal to T kasi that is for singly. Kasi isa lang ang stress diagram nun ng singly. Ito lang. But on the doubly side, ito na yung stress diagram niya. Dalawa. So now, before we have the static equation, syempre kailangan muna natin i-check yung steel stresses. So, check natin yung steel stresses. Kunin natin si F'(S). Si F'(S) natin, that is 600 times C balance minus D prime over C balance. Substituting the value, we have 600 times C balance is 3,000 over 13 minus the D prime, which is 72 divided by 3,000 over 13. Now we have an F'(S) equivalent to a value. So that will be 2064 over 5. So this is in megapascal and the approximate value is 412.8. So this is lesser than 414. Therefore, we have to use F'(S) of 412.8. Next, yung Fy naman or yung Fs naman natin. So that is Fs is equal to 600 times D minus C balance over C balance. So that will be 600 times the D is 390 minus our C balance is 3,000 over 13 divided by 3,000 over 13. Our Fs now will be equivalent to a value 414 megapascal. As you can see, this is equal to our Fy. Therefore, this is assumed to be yielding and we will going to use the Fy, which is 414. Now, going back to our static equation, so gagamitin na natin yung C1 plus C2 is equal to T since this beam is proven to be a doubly reinforced beam. So now we have C1 plus C2 is equal to T. So that is 0.85 F'C A balance B plus A'S. So since nakita natin dito kanina that the steel is not yielding for the compression, so that will be F'S minus 0.85 of our F'C. That is equal to AS balance Fy. Bakit ito lang yung may AS balance? Kasi yan yung pwede nating kunin as balance steel ratio. Yung compression naman kasi wala siyang A'S balance eh. So, getting this one, kasi that is just an excess moment. And the main concern here is the tension reinforcement. So, we could say, coming from this equation, that AS balance is equal to rho balance times BD. So, substituting the values we have here, 0.85 F'C A balance B plus A'S times F'S minus 0.85 of our F'C is equal to rho balance BDFY. So, arranging the term to get our balance steel ratio, we have rho balance is equal to So that is 0.85 F prime C A balance B plus A prime S times F prime S minus 0.85 of R F prime C divided by B D F Y. So now, we have to substitute the values na nakuha natin kanina at yung mga given values natin. So we could have 0.85. So that is 0.85 times 28 times yung A balance natin, which is 2550 over 13. Double check lang natin. Times B is 350 plus yung A prime S natin is 200 pi times F prime S is 2064 over 5 or yung 412.8. That is multiplied by or minus 0.85 times F prime C times 28. So then that will be divided by BD. So that is 350 times 390 times 414. Now we have a raw balance which is equivalent to a value 0.033239. So this is our raw balance for Doubly. Compare natin dun sa raw balance natin ng singly. So kunin ko na lang yung derived equation dun. Yung derived equation natin for raw balance ni singly. So for singly, so ayun nga, for singly, so isin lang natin. So for singly, we have here yung equation na derived, which is 0.85 F prime C beta 1 over Fy times 600 over 600 plus Fy. So substituting yung values, we have here 0.85 times 28 times 0.85 divided by 414 times the value 600 over 600 plus 414. Our raw balance will be equivalent to a value 0.028. That is 914. So this is for the singly. So as you can see, mas malaki yung balance still ratio for the Doubly kaysa kay balance still ratio for the singly. So eto ngayon yung reference point kasi para ma-determine natin kung nag-over-reinforce yung beam natin o hindi. So eto para sa singly, since hindi naman singly yung beam natin, so ito is wala nang hindi na siya magiging reference. Ang magiging reference natin yan is yung for Doubly, which is ito, which is 0.033239. And from our given problem, as you can see, yung raw actual natin na to is 0.035, which is exceeding yung balance still ratio natin. And from this one, we can conclude na over-reinforce yung beam natin. So, ibig sabihin, kaya naging ganun yung conditions nung ating yielding ng steel. Kasi nga, na over-reinforce siya mismo dun sa problem. So, ibig sabihin, kung susundin natin yung code provision, we have to redesign this one kasi hindi natin ma-attain yung ductility nung beam natin. So that is the use of getting our raw balance or the balance still ratio. So yun yung mangyayari for the balance still ratio on the Doubly part. So mas mataas siya kaysa dun sa singly. Ngayon balik tayo naman dun sa maximum still ratio. Sa maximum still ratio, syempre, sa maximum still ratio, ang ginagamit kasi natin dyan yung strain diagram pa rin. which is ito 0.003 at alam natin na ito 0.005. So, kunin na lang natin yung diagram sa taas. So, ito siya. So, kung yung diagram na yan yung gagamitin natin, to get the maximum still ratio. So, ngayon, kung gagamitin natin yan, so we could have, so gawin natin tong Cmax, tas dt yan. So, we have Cmax over 0.003, then this one will be 0.003 plus 0.005 over dt by using yung bigger triangle ito. So, now na meron na tayong ganyan, we arrange the term. So, may iwan si Cmax dito. So, sorry, ito pala baliktad. So, this should be dt over 0.003 plus 0.005. So, getting that Cmax, ngayon, we have here 0.003 over 0.003 plus 0.005 times dt. So, this one will give us a value 3/8 of dt. So, substitute natin yung value natin ng dt, which is 3/8 times the dt, which is 422. So, we can have 633 over 4 mm as a value of Cmax. And, pwede na tayong kumuha ng Amax, which is equal to a value beta 1 Cmax. Coming from this one, we could have 0.85 times 633 over 4. And this one could be 10,761 over 80 mm. Siyempre, bago tayo ulit mag-proceed in getting the the maximum still ratio, daan muna tayo dun sa still stress niya. So, yung F'(S) natin for the condition of the maximum will be 600 times Cmax minus D prime divided by Cmax. That is equal to a value. So, that is 600 times 633 over 4 minus 72 divided by 633 over 4. Now, we could have an F'(S) equivalent to 69,000 over 211, which is approximately 327.0142, and that is lesser than our Fy. Therefore, we have to use F'(S). Then, for the part of the tension steel, we have Fs is equal to, that is 600 times D minus Cmax over our Cmax, which will be equivalent to a value 600 times 390 minus the Cmax, which is 633 over 4 divided by 633 over 4. From this equation, we have an Fs equal to 878.673, which is greater than the Fy. Therefore, we have to use Fy. So, ngayon, saka tayo papasok dun sa part ng static equation na C1 at C2. So, for the C1, we have here C1 plus C2 is equal to T. So, C1, syempre, ganun pa rin yan, 0.85 F'C. But this is A max B plus A'(S). So, hindi nag-yield yung steel natin. So, that is F'S minus 0.85 of our F'C. And our T will be AS max times Fy since nag-yield yung steel natin. So, yung AS max dyan, pwede nating kunin as raw max BD. So, substituting this value, we could have 0.85 F prime C A max B plus A prime S times F prime S minus 0.85 F prime C is equal to raw max BD Fy. Arranging the term, we could have raw max is equal to 0.85 F prime C A max B plus A prime S times F prime S minus 0.85 of R F prime C divided by BD Fy. So, substituting our values, we could have 0.85 times 28 so this is 0.85 times 28 times our A max, which is 10,761 over 80. Check natin. So that is times 350. Tapos plus yung 200 pi, which is multiplied by 69,000 over 211 minus 0.85 times 28 divided by B, which is 350 times 390 na D times Fy na 440. From this one, we could have a raw maximum equivalent to 0.023199. And as you can see, this maximum steel ratio is for Doubly. So, ang maximum steel ratio natin for singly is mas mababa compared dun sa Doubly na yun. So, ang raw max kasi natin is 0.019828. For Doubly, that is 0.023 as you can see here. Yung raw actual pa rin natin mag-exceed dito. And as you can see, hindi na siya beam type at masyado na siyang madaming layers kung dadagdagan mo pa ng isang layer ng reinforcement. And this is now considered as a compression member kasi para na siyang column na multiple layers yung reinforcement. So, dito pa lang makikita mo na bakit ganun yung naging behavior nung sample problem natin na beam. So, ito yung mga properties na mahalaga din sa pagdedetermine ng behavior ng ating reinforced concrete beam. So, that will be all para dito sa ating sample problem number 2. Hope you have learned something. Again, this is Engineer Rodolfo. Thank you for watching and don't forget to subscribe to Butch TV.